Hi everyone, this is Mrs. Snowbeck. Today we are going to cover Unit 1, Lesson 3 on linear measure. As you recall, in Unit 1, Lesson 2, we talked about lines. Well, today we're going to talk about segments of lines. And so a segment of a line is part of a line. Part of a line with two endpoints. So an example of what a segment might look like is you might see a segment like this and it has actually dots at the end of it. Maybe this point is A and this point is B. That's an example of a segment. And the way that you would name that segment is you would say capital A, capital B with a bar above it. Notice there are no arrows. Okay, so a segment is just part of a line. So, next question. Can you find the length of a line? Think about that for a second. If you're kind of thinking lines go on forever, and how would you ever be able to measure that? You're correct. The answer is no. You cannot measure the length of a line. It goes on, or it goes in both directions. It goes in both directions forever. Any Sandlot fans maybe catch that reference? Next question. Can you find the length of a segment? Well, in this case, it's just part of a line. Do you think you could measure that? The answer is yes. You can measure a segment. You could get out a ruler or a tape measure and you could measure the length of a segment. It has a start and an end. It has a start and an end. Now remember, the two symbols are a little bit different. Like if I was talking about line AB, it's AB with a double arrow. And if I'm talking about segment AB, it's AB with a bar with no arrows. Okay, so try to keep those straight. Point S is between points R and T. So take a look at this picture. Would you agree S is between R and T? The answer is yes. Does that necessarily mean it has to be right in the middle though? And the answer is no. So it's just somewhere between R and T, but not necessarily right in the middle. But if you take this distance from R to S and you take this distance from S to T, if you add those two smaller distances together, would it be equivalent to the distance from R to T? And the answer is yes. So this is how we write that. If we take the distance or the segment, if we take segment RS and we add it to segment ST, so we add the two smaller ones together, it will equal the segment from R to T. So I also want to talk about distance, the distance between 2 points. That's like the length between 2 points. Like maybe you actually take your tape measure out and you measure the distance from R to S, for instance. Well, there's a symbol for that too. We write that without anything on top. So for instance, if you saw just RS, this means the distance from R to S. So there's three symbols. You could have line RS. This is line. You could have segment RS with the bar above it. And you could have just a regular plain old RS with nothing above it. And that means the distance from R to S. So you're going to see these three different symbols, or lack of symbols, throughout this chapter and throughout geometry. So let's get into the good stuff. Y is between X and Z. So pause the video, try to draw that. Y is between X and Z. If you drew something like this, that's a great representation. Y is somewhere between X and Z, not necessarily in the middle. And then it says, find the length of the segment from X to Z, given that from X to Y is 4.5 centimeters. So let's put that on our picture, 4.5 centimeters from X to Y. And segment YZ is 3.2. Now my picture is not drawn to scale, but that's okay, it doesn't matter. And they want us to find the length of segment XZ. So how can I get the total distance from X all the way to Z? Well, remember the two small ones added together equal the big one. So I'm going to take 4.5 plus 3.2. If you need to use a calculator, that is great. That's fine. Go ahead and do that. I'm just going to add it by hand. Looks like I get 7.7. And we want to label. If the question has labels in it, then I need to label my answer. So it's going to be centimeters. Go ahead and try this one on your own, and when you're done, check and see if you have it right. So pause the video, try it on your own. So here's my drawing. Notice I labeled where the 4.625 and the 2.5 are, and now I'm going to try to find the distance from A to C, and so I'm just going to add the two shorter ones together. Go ahead and use your calculator if you need to. I'm just going to add these by hand. And it looks like I get 7.125. And you know what? They don't have any labels in their question, so I do not need to label my answer. Take a minute and draw number 3 and label all the parts in the picture, okay? And then unpause the video and we'll do this one together, but draw it first. So you can see my drawing here, everything's labeled, and it says this, it says find X and ST, the distance from S to T, if T is between S and U. So you can see T is somewhere between S and U. I've labeled all the parts, but in this case, they also told us from S to U is 45. So remember what we said before. We said if you take the two smaller parts and add them together, it will equal the long part, or the entire segment. So the two smaller parts are the 7x and the 5x plus 3. If I add those together, so it's going to look like this, 7x plus 5x minus 3, together added up, they should equal 45, because 45 is the length of the whole segment. Now we can use our algebra skills. So on the left side, we have two variables. We can combine those. 7x plus 5x is 12x. The next thing I want to do is move that constant. I have a minus 3, so I'm going to do the opposite. I'm going to add 3 to both sides. Here they're going to cancel out. So I have 12x on the left, and I now have 48 on the right. And then I want to get rid of that coefficient. So right now it's 12 times x. So to undo that, I'm going to divide by 12. They cancel. X equals, and now you have to figure out what's 48 divided by 12. Use your calculator if you want. You should get 4. But we are not done. If you go back and read the question, it says find x and ST. Now ST is this distance up here. So what are we going to do to find ST? Well, I'm just going to do this. ST equals, that means the distance from S to T. And see how it's 7x? Well, x is 4. We just figured that out. So it's going to be 7 times 4. 7 times 4 is 28. And that is the distance between S and T. Again, they don't have labels, so then we don't have to worry about labels. Please try number 4 on your own. So pause the video, give it a try, and then unpause the video. So y is between x and z. So I'm going to draw my segment, and now I'm going to label my stuff. So from x to y is 3a. From x to z, oh, that's the whole thing, is 5a minus 4. And from y to z is 14. Now, remember, the two small parts added together equal the big part. So the two small parts are the 3a and the 14. So if I take 3a plus 14, add them together, it should equal the whole big part, which is 5a minus 4. Again, use your algebra skills. I have variables on each side of the equal sign, so I'm going to get those to one side. I'm going to move the 3a. It's a positive 3a, so I'm going to subtract 3a from both sides. I end up with 14 on the left, and on the right now I have 2a minus 4. Next, I'm going to move the constant, which is nearest to the variable. So in this case, I'm going to move the 4. It is a minus 4, so I have to add it to get it to the other side. I have to do the opposite. These cancel out. So now I have 18 equals 2a. Get rid of the coefficient, so it's 2 times a, so I'm going to divide by 2 to undo it, and then I wind up with 9 equals a. Now, read the question. It says find a, which we did, but it also says find xy. So to find xy, you're going to have to take that 9 and plug it in for xy. So xy is going to be 3 times 9, because a is 9. 3 times 9 is 27. They do not have labels, so we are done. Last but not least, let's talk about the word congruent. If two things are congruent, they are the same size and the same shape. So look at these two segments down here at the bottom. In this case, segment MN is 2.1 centimeters, and segment QP is also 2.1 centimeters. They have the same measure, so they are congruent. Now, it's really small right here, but this is the symbol for congruent. I'm going to write it down here. It's an equal sign with a squiggle above it, the symbol for congruent, okay? So if I wanted to, I could do this. I'm going to erase my little arrow. So here's what I can write. Segment MN, now remember it's a segment, so I put a bar above it. It's congruent to segment QP, because they're both 2.1 centimeters. And I put that symbol with the equal sign with the squiggle above it in the middle. So they are congruent because they have the same length, or you can put the same measure. Either word fits in there. So on a figure, we know two pieces are going to be congruent if we see something like this, where they both have the same measure, 2.1 centimeters, but you also might see something like this triangle here. Do you see how two of the sides have a tick mark on them? That means those two sides are the same length. Or here we have a parallelogram, and we can see some sides have one tick mark on them. That means those two sides are congruent, while the other two sides have double tick marks, so they're congruent. But all four are not congruent to each other. So on a figure, you will know if two pieces are congruent if you see matching tick marks. Great, you guys. Give Unit 1, Practice 3 a try. If you have any questions or get stuck, just send me a message. Okay, have a great day.